This material is made available to you by or on behalf of the University of Melbourne under Section 113P of the Copyright Act 1968. It may be subject to copyright. For more information, visit the University Copyright website.
Okay, let's get started. Thanks. Okay, so I hope you're all gone well with regards to the homeworks and so forth. If you have any questions, of course, you're all making good use of the discussion boards, and there's lots of back and forth. And so, yeah, please do use that resource, and please check on other people using that resource as well. Are there any questions from previous lectures or anything you want to start with? You can always grab me afterwards if you have questions, of course. As for today, we're going to be talking about a new topic, which is part of speech tagging. This is a form of syntax. One of the simpler forms of syntax, where we're looking at ascribing syntactic properties of each word. And I'll just motivate that first with regards to some other tasks that we've seen thus far, and some tasks that we haven't. In this case, when we were talking about text classification, one of the tasks that was used as an example was authorship attribution. So, and we talked about various features that we're going to use for authorship attribution, and I just want to illustrate one that's kind of going to help to motivate what we're going to be talking about today. So if we have some training data like as follows, we'd like to be able to classify whether or not each of these sentences came from Sam or Max. We can see here that there's a bit of a syntactic clue as to who is the author here. And if we were to see another sentence like this one here, again, we see that one of these sort of linguistic clues, syntactic clue as to who it might be. Now, each of these different sentences are on very different topics, very different subjects and objects in terms of the initial noun phrase. One's about lunch, one's about a bookstore, and so forth. But we can see here that they've got a similar structure, certain ones of them, right? So we see was something being used a lot of the time. So we can see that they've been expressed in a certain way. They're all in past tense, but some of them are in passive voice. So Max here in the training set has said two things that were in passive voice. The hospital was cleaned by the janitor rather than the janitor cleaned the hospital. These are two perfectly valid ways of saying the same thing. He elected to say it a certain way, which might give us a clue as to his identity. Lunch was served at 12 p.m. Is another thing. So another similar construction. So these, if we see things using these kind of constructions, these aren't captured very well by bag of words representation. If we just look at the words, we're not sure if the word was here is operating to put the sentence into the passive versus the active, or if it's just describing a property. So actually now looking at the lunch was served at, I think there's no other way of saying that one, so that's actually an interesting example. But the point I'm trying to make is that this is one of the kind of sort of fairly subtle syntactic variations which gives rise to a key feature in authorship attribution. So we'd like the computer to know this. We'd like a computer to be able to detect, say, where we have passive versus active voice. And one way of doing this is going to be part of speech. This is going to be how we get at this syntactic structure of the sentence. Another example, and this is a topic that we're going to come on to later in a few weeks' time. In fact, I believe next week, is information extraction. So in the case of information extraction, we're given a sentence and we're interested in which things are being talked about in the sentence and how they relate to one another. So in this sentence, Brasilia, the Brazilian capital, was founded in 1960. We'd like to see that certain knowledge has been captured in this sentence, has been represented in this sentence. One is that Brazil has a capital city and its name is Brasilia, and that the city of Brasilia was founded in 1960. So this is the kind of thing we often do when we're trying to create knowledge bases. We're looking in text and we're trying to pull out knowledge fragments from the text. Now, in order to do this, first we need to be able to work out what are the likely items that are going to be filling these roles in these relations. So each of these is sort of written in a logical form with an operator and two arguments. What kind of words are likely to fill these roles of arguments? What kind of words are likely to relate to these operators? So we can see here that words like Brazilian, Brasilia as a proper noun is going to be one of these things that is kind of likely to appear as an argument. Brazilian as an adjective is also likely to give us a clue that it's going to be in one of these relationships. Things like numbers, and there are also certain classes of verbs that are going to be useful for this. So the verb of founding is going to be useful if we're interested in creating knowledge bases like Wikipedia info boxes and these kind of things, right? So a first step of how we might approach this problem is to try and characterize, run over this sentence and say, well, this is a noun, this is a determiner, this is an adjective, and so forth. And thereafter, we'll do further processing to try and obtain this representation. So I'm not going to talk through how we do this. I'm just going to talk through about the first step at the moment, and we'll come back in later lectures to how we actually go about that process. Okay, so the outline for today is that we'll cover what a part of speech is, and then various tag sets, various inventories that people have come up with to try and characterize the language. We'll be talking about ones in English. There are ones for lots and lots of other languages as well. So these are ways of characterizing the certain classes of words that exist in the language. And then finally, I'll talk about how we automate this. So by and large, this is a supervised learning problem. I'll talk about some supervised learning approaches briefly at the end that we can use to do this tagging automatically. Okay, so now this lecture is going to get a little bit more linguistic-y, so be warned. Because in describing what a part of speech is, we have to go into sort of examples and the various constructs that we see in language. So by and large, we split the part of speech into open and closed class. So open class are the words that are the categories that tend to have lots and lots of words in them. Things like nouns. If you look at the number of different nouns in English, there are many tens of thousands or hundreds of thousands. In contrast, there's closed class, which mainly perform syntactic roles, of which there are very few of them, and they don't change very much. So we have a small set of things, and I'll give you some examples of closed classes in a sec. Now, largely, so I'll go through each of the classes. So first one being nouns. So we have things like proper nouns, like Australia, so typically are capitalized in English, referring to a specific thing, versus common nouns, referring to a class of things, in this case, wombat. We have mass nouns versus count nouns. So can you put an S on the end? If we're talking about water, water by and large is a mass noun, unless it's in a bottle, and you can say, I'll have 3 waters. But by and large, that's a very strange usage. You can use it only in some certain situations. By and large, you would have to say, I'll have some water, but you can't quantify it. Now, verbs, the other major class of open class words. There are a couple of others that we'll get on, categories we'll get onto in a sec. So verbs are interesting because they have rich inflection. We talked about this when we were talking about morphology, in that we have agreement, we have tense, we have all these other aspects that affect. So in this case, we have the verb to go, but we've got all these different variants of the same word. We have things like auxiliary verbs, like be, have, and do. They don't really do that much, but they're a class that fits as a subclass of verb. We could call these auxiliary verbs as a closed class, because there's, in English, these words are very limited. we have a fairly fixed inventory and they have a very specific syntactic and semantic meaning. Okay, and then we have transitive versus intransitive verbs. This is to do with how many arguments they expect. So the example I have here, I wait expects a single argument, I. Peter hits a ball. Peter and a ball. There are 2 arguments, so it's a transitive verb. Peter gave Mary the ball. So Peter, the ball, and Mary, there are 3 arguments. So this is what's called ditransitive. So different types of verbs expect different numbers of arguments, and this is called transitivity. I won't go through all of these properties. I'm just pointing out some of the more important properties of each of these verbs. And this is sort of, when we look at the class of verbs that are very large, we sort of tend to split them into smaller subparts, subgroups, to reflect their different properties. So the other 2 open classes in English are adjectives and adverbs. So adjectives, we have different versions. I won't go into this in detail. Adverbs, we have many different types of words that operate as adverbs. So these might be changing the manner of the verb. So to walk slowly operates as an adverb. It changes the meaning of the verb. But we can say to walk here operates as an adverb. It's doing it in a different way. It's giving a location, and so on and so forth. We have various different kinds. So these are an open class in that you could make up a new word and you could slot it into one of these classes and someone might understand what you're talking about. So new adverb like slumpily or something. I walk slumpily along. I just made it up then. It's not a real word, but it would be happily accepted in some context, and that's a property of an open class. Okay, so those are the open classes. Now in English, and by and large, the open classes are fairly constant across different languages. The closed classes are very different and language specific. So I'll go through a couple of slides on the closed classes for English. And these, as I was saying, often have a more syntactic role in the sentence. They might be sort of a more finer point of syntax or have something to do with the semantics. They're largely not so much what you would call the content words. They don't tend to be the kind of things we search for in IR engines so much, but they're very important for understanding the meaning. So prepositions, things like in, of, on, for, so forth. Now, there are regular prepositions. So on the table, he put it on the table. On is operating in a fairly regular way. But we often have things that we call particles. So turn it on. On here has no meaning. It's part of the verb, really. Turn on is effectively a verb, but it's written as 2 separate words, and you can chuck stuff in the middle. So turn the television on, we've added extra stuff in the middle, but turn on is operating as a fragment. And there are other words like that, ring up, tone down, etc., etc. So often it's a preposition that's behaving as part of a verb. We call that a particle. Can be quite hard to try and determine automatically if the word is operating as a preposition or a particle. It's a complex challenge. So determiners are another one. So we have things like articles, like a, the, and so forth. We also have demonstratives, that, these, and so forth. We can have quantifiers. We can have numbers. These kind of things are all what we call as the class of determiners. Now, for anyone learning English as a foreign language, you're probably reasonably familiar with all of these different classes because you would have had to learn them, and they often behave quite differently from your language. So people, for instance, from China trying to learn English are going to have to struggle to try and learn what's the appropriate determiner to use in different contexts. It's not always obvious. And learning prepositions is another one that's, particularly difficult case. So another class of closed class words are pronouns. These are particularly important. So these are, like I, me, she. You can have possessive ones like my or mine, and so forth. You can have interrogatives like which, what, who, and so forth. These are typically well, they're kind of important because they're often the start of a sentence. They're often part of the core meaning of a lot of sentences. Okay, and so just continuing on in closed class, we have things like conjunctions. So these are words that we use to combine things together to make larger sentence fragments. So a standard conjunction is something like and. So if we're presenting a list, we have multiple arguments, we glue them together with an and. There are other kind of words that we can use that have a similar structure, things like ifs, all those, and so on, which sort of indicate that there's going to be a more substantive phrase coming next. And then the last one I'll talk about is modal verbs. So I was talking before about some of the verbs, I was saying the whole class of verbs is open, but some subclasses of verbs are a closed class. And so things like can and could, and I think might and shall and so forth, all of these verbs, there's a very limited set of them that are giving us these types of meanings. We tend to use them in concert with other verbs a lot of the time, and they tend to sort of give a bit more nuance into the meaning. Okay, and there's quite a lot more. I've just gone through the highlights here. Yes?
So in the very first example with Brasilia,
Yep.
you mentioned the number. So in that case, like 1960 is kind of years, is that now? How do numbers?
Yeah, that's a good question. Yeah, so I think in that case it's kind of operating more as a noun than a determiner. Because if you're saying I want 1,960 apples, then it's behaving more like a determiner. It's quantifying something. If you're saying 1960, it's behaving more as a noun. Yeah, and I'm not sure how that's processed. I think actually in a lot of the standard tree banks, the resources that were created for basically looking at syntax and looking at part of speech, they were very careful not to go into too much detail about noun phrases because it gets very tricky to basically determine some of these decisions. And so I'm not sure if it's sidestepped that we have this special cardinal category that can be sort of a noun and it can be a determiner. I think, yeah, I'll have to look that up to see exactly how they're handled. But yeah, it's a good question. Okay. So,
When you say that those words are very different across languages, you mean that, for example, the languages themselves have determiners?
yes. Yes. And there are languages that supposedly don't have adjectives. I'm not aware of them, I don't speak them, but my understanding is that some of these classes are not uniform. Like, by and large, all languages have nouns and verbs, but as for the other categories, it's a little bit more fluid in terms of different languages. I think most languages have nouns, verbs, and adjectives, but sometimes it's a little bit of, sometimes the categories bleed into one another. And particularly when you get to the more fine-grained classes, then they're very different across different languages. Okay, so one of the problems, so once we have sort of categorized, saying, here are a whole lot of words, these are the sort of, by and large, the most interesting parts of speech. These are the classes that we're interested in. Then if we look at various sentences, we see that there's a certain problem, that trying to work out the part of speech in context can be a non-trivial issue. So here are two classic examples. So we have time flies like an arrow and fruit flies like a banana. So these sentences have been chosen to be a bit silly, but and to mirror one another, right? So you could process them the same way. You could treat them as being the same sequence. But in actual fact, when you look at them and you think about their actual meaning, they're quite different. So time flies like an arrow. Time is a noun. We're talking about time on your watch. Flies is operating like a verb. We have a preposition for like, a determiner, and a noun. Now, in fruit flies like a banana, again we have the flies like a versus an. But we see here in this case, fruit flies is being treated as a noun together, right? So there's such a thing called a fruit fly. It's a type of fly. and they like to eat a banana. So like here is operating like a verb in this context, whereas it's operating like a preposition here. Flies is operating as a verb versus a noun. So being able to say each word, this one is definitely a verb, and this one is definitely a noun, that just doesn't work. Language is ambiguous. You often have words that can fit into 2 or 3 or 4 different classes. Flies and like are not that uncommon in that way. And here's a few examples. So people like to play on these kind of ambiguities with silly newspaper headlines. This is sort of part of the fun of being a journalist, I think, coming up with silly headlines. So if we look at the bottom one, for instance, eye drops off shelf. So in this case, are you talking about eye drops, like the item that you might buy from a chemist, and off shelf means that they don't stock them anymore, versus the intended misreading that you're supposed to get when you read it about someone's eye rolling and falling off a shelf. So yeah, these are all examples where there's 2 readings of part of speech and one of them's intentionally humorous. There's a great long list of this that this came from, which are quite fun to read. Okay, so I've talked about sort of some broad classes of part of speech, but when people create a lot of the large resources, tagged resources in English and in other languages, they've come up with their own tag sets as part of this. So instead of just saying noun determiners, a lot of times they're a lot more specific, and they say, oh, this is a singular noun, this is a plural noun, or this is a pronoun, this is a possessive pronoun, and so on and so forth. So we have this idea of a tag, which is this classification target, a classification label by and large. We often write them in uppercase, and they often include some kind of inflection, like past tense verb, singular, and so on. Now there's a whole lot of different data sets that have been marked for part of speech. Almost, well, I don't know, maybe I'm exaggerating, but most of them have their own tag set. So when people create a new data set, they realize that there's some deficiency in the old tag set, so they come up with their own. So here I've listed 4 different tag sets. So the Brown and the BNC are quite, and Penn Tree Bank, they're all data sets that have been around for 15, 20, 30 years. And they've all got their own specific tag sets for English. Now, if I extended this out to other languages, you could fill up the slide, all the white space in the slide with all the different tag sets for different languages. And again, you have the problem when 2 people create resources, say in Chinese, they'll come up with different tag inventories when they decide to look for certain different things. Now, the universal one that I've got down the bottom was an attempt to try and harmonize these, to bring them together. And largely what we've talked about thus far are universal tags. They're tags that are fairly common across most languages. So in the universal tag set, I think it has 1 tag for noun and 1 tag for verb, for instance. It doesn't make all these fine-grained distinctions. And it ends up with 12 tags. They're not completely universal, but they're a reasonable approximation. And they've done that by basically mapping between each of the tag inventories to a common base set. Okay, so the Penn Tree Bank tag set is the one that is most widely used in English, and it's the one I'll talk about for the next few minutes. Now, everyone gets scared when they see this tag set because it's 50 or so elements, and they've all got these strange codes. And people are scared, saying, oh, do I have to remember all these tags? Not really. I'm happy for you to know what a noun and a verb and an adjective and a determiner and a preposition are and so forth, right? The few core categories, it doesn't really matter too much to know in too much detail. It's worth knowing that the tag set exists and does go into more detail, but I'm not expecting you to memorize these labels. So the major tags, they do them as 2 or 3 letter codes. NN meaning noun, JJ meaning adjective, VB meaning verb, and so forth. And these are all the categories that we've seen in the last few slides, by and large. And yeah, so one thing that's kind of interesting is that we have this category 2, which has 1 word in it, 2. which is kind of a weird label, but to behaves really strangely. You can use it to make a verb in the infinitive to say, to be. You can use it as a particle as well, as part of a verb particle construction. You can use it as a preposition in some cases. But by and large, there's some interesting decisions made as part of creating these inventories. And some of these are very large classes, like noun has many, many, many members, and other ones are very small. Okay, and I'll show you these in a little bit more detail. So just illustrating some of the more common tags. So for noun, we have NN, which is a singular noun. I haven't shown you an example of that, but wombat would be an example. We have NNS. The S means it's plural as a suffix. The P means it's proper. The PS means proper plural. So Australians in this case. So these are the kind of things back on that example of information extraction. NNPs and NNPS, they're going to be kind of some of the things we're really going to be looking for when we're doing this, for instance. Now, VBs have 7 or 8 different VB something suffixes. They correspond to different versions of the verb. So we have the infinitive, which is VB. We have VBP, which is the present in first or second person. Now in English, they're the same. So I eat, you eat. VBZ is the third person, she eats. And then you have different tenses like past tense, VBD. We have the gerund, eating, when you have an ing form. And we also have things like past participle, VBM. Now, other languages are going to have more or less of these, depending on how much morphological variation they have in their inflections. Similarly, the other categories, you extend them like adjectives. So an adjective like nice, and then you can change it to a comparative to say nicer, or a superlative to say nicest. So that's the R and the S suffix. So by and large, once you have a look at this, it looks a little bit cryptic to begin with, but once you realize that the first 2 characters usually encode the key information, and the last character or 2 are just basically modifying that slightly. Okay. The dollar at the end indicates a possessive, so going from me to my, you put in a dollar and it means it's something that's owned by, it's possessing ownership. And similarly, you can do that with the WHs, so they try to be consistent across the different labels, by and large. Okay, now I'm not going to go into this in huge detail. You can read more about it in the reading. But again, I'm not expecting you to memorize all these categories. I'm just trying to illustrate the breadth of the inventory and the complexity of this problem. Now, what we see in these tagged resources, so the Penn Tree Bank being one of them, strings of the form like this. So you can see here, each word has a slash and then it has its tag. So that is a determiner, DT. Limits is a common noun, NN, with an S, meaning it's plural. And so on and so forth. And so this is just the typical way that we might see it written. And this is what you'll see. This is just the format in which it's written in the Penn Tree Bank. Okay, so what we'd like to do is we'd like to automate this. So the Penn Tree Bank has 50,000 sentences or so that have been annotated like this. They've also been annotated for other things, which we'll get to in future weeks for syntax, like the hierarchical structure. But for the moment, we'll just look at it as part of speech, which is the first step. We'd like to be able to learn from that and automate this process so that humans don't have to sit there and laboriously say, this is a preposition, this is a determiner, and so forth. And if we can automatically pos tag, that's one of these technologies that we can use almost everywhere. So we can use it to do better morphology. We need it to lemmatize words, so we need to know what part of speech they are before we can figure out how to normalize them to a dictionary form. Now, some applications we might be more interested in nouns. Others we might be more interested in verbs, say, like the example for looking at information extraction. Now, information retrieval, you might think we're going to focus largely on the open classes, especially nouns. So maybe we want to part of speech tag our query or part of speech tag our documents and use that as part of our pipeline. In deciding what snippet to show as well, maybe that's sort of something that part of speech could come into as well. They're useful for many classification tasks. They're useful for word sense disambiguation. This is a bit like the lemmatization problem in that these words are very different. Cross as a noun, cross as a verb, cross as an adjective. These are all quite different words. And once we know that, then we have a clue as to their meaning. And we can use that wherever we're going to need their meaning. And we can use them to create larger structures. So this is a fundamental thing for parsing. To understand the structure of language, we need to know what each of the words are. Okay, so how are we going to try and do this in an automated fashion? So automated taggers, there's a whole bunch of different things. I'll talk about a few of them. So one stream of work that's been done a lot in the past are rule-based taggers. So the idea is trying to do it by hand, create a whole lot of rules. And then motivated by the fact that that's very slow, there have been a lot of statistical taggers created. So I'll talk about a few different ones, and we'll carry on in a future lecture. I think the next lecture will talk a little bit more about ways of doing this using more modern techniques, deep learning. Okay, but let me talk a little bit about rule-based tagging first. So typically what you're going to start with is you'll have a word or a lexicon where you list all the words, and you're going to say this word can take on these different parts of speech. So for instance, like, from the example before, that could be, what's that? That could be a verb, it could be a preposition. So for like, we'd have this entry saying verb and preposition. Maybe it can take on other part of speech categories, so we might add them too. But the idea is that we're going to start with this list of possible tags. We may include other information, so we might say that this word is a particle that interacts with this verb in particular. So up is part of ring up, so we might have this information in the lexical resource as well. So once we have this lexical resource, now we're going to apply this to words in context. And we'll look to see what their possible labels are. And then we'll have a whole lot of horrible, complex rules to try and eliminate the bad examples, the bad instances, right? So if we have a word, if we have a word that's labeled as determiner, we have something after it that might be a verb, that's pretty unlikely. You don't tend to have determiners followed by verbs. Determiners tend to be followed by adjectives or nouns. Because of that, we can basically eliminate some of these options, and basically we have lots of rules to try and eliminate these options until we end up with an unambiguous string. And a lot of these rules are based around some constraints of grammar, that certain words or categories are unlikely to co-occur next to one another, and other effects like this. But this hinges on us having a very rich lexicon in the first place that has all the information we need, and it hinges on us having all these rules about the structure of language. So were you to spend a lot of time and create a really good rule-based tagger for English, and then you try and apply it to Spanish, you're going to have to start again. And then you apply it to Croatian, you have to start again. So you're not learning something that's portable. It's something that could be actually done reasonably well from data. So by and large, most people use data-based techniques, yes? There are, well, so mainly in the 70s and 80s, there were some rule-based taggers that were quite prominent, but then by and large, they're sort of rule-based but statistical refinement. And there's something called the Brill tagger that's based around that basis. So it starts off with a rule-based approach, but then it's learning these rules automatically. So by and large, well, if you rewound 30 years, yes, but these days, not really. And they just get so complicated so quickly that they don't tend to get used that much. There's something called Snowball, and there's something called the Brill tagger. I can't remember exactly how Snowball works. I think it has some rules, some hard, fast rules inside it, but I think it also has some learning as well. Just simply because the coverage of any of these things is pretty limited. It's limited by your lexicon, and there are always going to be words that don't exist in your lexicon, or you've associated them with the wrong part of speech in that they should have another part of speech, but you didn't realize it at the time. Like, if you looked at the word like, you didn't think about that it could be used as a preposition, then your lexicon's going to be incomplete. So yeah. But yeah, there are some really gargantuan rule-based systems, like rule-based translation is one of them, where people have worked on the French-English translation system for Sistran, which I believe has something a bit like a rule-based tagger as its first step. They've worked on it for 30 or 40 years now, and they never released it in the wild. So they use it for business clients, but they never actually released the code, and I believe no one really actually understands how it works anymore because it's so complicated and it's just built up over the years with all these rules. So, yeah. Okay, so unigram tagger. So the first statistical tagger, this is really straightforward, just as giving a baseline. It does reasonably well. So the idea is that you go through a large training resource, you work out how many times each tag occurs with each word, and you count them up, and then you just basically look up and you say, I'm looking up this word, what is the most common tag that we've seen with this word? So it's a very straightforward way of tagging. For instance, with our like example, we can use this and we can say like more often occurs as a verb than as a preposition. So whenever we see like, we're just going to tag it as a verb. Now, that's obviously not going to be adequate in the context like the examples that I showed you, but it's going to do well most of the time. There's a lot of the time the predominant class, either words have a single class or they have a few classes, but one is much more common than all the others. And because of that skew, this is a pretty good baseline. Okay, and there's an example doing exactly that in the notebook that you can have a look at. Okay, so there's, if we're trying to do this in a slightly more accurate way, then we might build a classifier to do it. Like, instead of just looking at a unigram model, which is effectively a classifier with no context other than just the word, we might look a little bit further afield and look at the local context in a little bit more detail. So we could frame this as any of your favorite classifiers, like logistic regression, could be k-nearest neighbor, SVM, whatever. And the idea is that we insert certain features into it. And the key thing is the target word, but we're also perhaps going to use a lot of information around the target word. So in our fruit flies like a banana, we'll potentially, I'll show you an example just to be, because I have the time, just to make it a bit more concrete. So that always makes it visible. Okay. Pen. Okay. Yeah. So if we have something like, that's the pen that you can't read. This one. You start again. So if we're looking at this, then we'd like to be able to say, so we know that we've got this, imagine this is part of our training resource that's been tagged. This guy's been called a noun. This one's been called a noun plural. This one's been called a verb. VB, is it VBP or I think it's VBP. Determiner and so forth. Now, if we're treating this as a training resource, what we might say is that we want to imagine we're trying to classify the word like. We're going to pass a window through and we're going to treat each word as a training example. The training example for like might say, for instance, maybe this is the context we're going to consider. I don't know. So we look to see that what's the current word? Word I. We might also have a feature of what's word I plus 1. A feature for what's word I minus 1. Let's just imagine we just look at that for the moment. We might also look at tag I minus 1 and tag I minus 2, say. And now what we're going to do is we're going to try and predict this guy. So this is going to be TI, and that's going to be the outcome of our prediction. So we're going to create a single data point for training with a representation of the 3 words and the 2 previous tags, and we're going to try and predict the subsequent tag. We can slide this little, whatever it is, this little Tetris piece across our data set, and it will then we'll be able to pull out the features for each window as we do it and learn to predict this next tag. And the idea is that the reason why we're doing this, right, is that looking at the word like on its own isn't enough. If we can see that like is followed by a, we'll think that it might be a verb. It's a pretty good clue. It might not be, but it's a reasonable clue. If we can see the word to the left, maybe that's going to give us a bit of a clue. If it looks like it's a nouny word, then maybe this is going to be a verb. But arguably, the biggest information is coming from what the previous tags are. So the fact that it was previously a noun means that it's pretty likely to be a verb. And looking at more than one of the previous words gives us just a little bit more context, or the previous tags gives us a bit more context to make that decision. Yep?
Is there a reason why you are not choosing, like, symmetrically the tag of A and the word for truth?
Because I want to apply this at test time left to right, because I'm not going to know these guys at test time. So I want to be able to slide this window through my data and make a prediction, and then I want to be able to make the next prediction already knowing it. So in this example, if I was trying to predict VBP here, after I predicted VBP, and let's imagine I got it right, and I predicted VBP, then I'd slide my window along to that, and I'd try and predict the next word. This is obviously banana, right? So usually you frame it left to right, just so that you can slide it across the test example left to right. The one thing I left out is that the tags to the left, you just have a special placeholder, like a sentinel symbol, like the start symbol or something, to say start of sentence, just so that you can make that first prediction of the first word. But the idea is that you usually structure this left to right. Not always, but there are methods where you actually use left and right context. The right context would be really useful. You're right. So that the next tag is going to be super useful for making this decision. It just makes the inference a little bit more tricky, so people tend not to use it. Are there any more questions? Okay, so I've got a little picture here showing a sequential model, and one of the things to emphasize is this error propagation property. So like what I was saying, if we're going to try and tag an entire sentence, we have to tag word 1, then we have to use that to tag word 2, then we use that to tag word 3. If we made a mistake on word 1 and got the tag wrong, then we might make a whole lot of mistakes, one after the other. So any error early on might affect the others and cause a whole lot of errors to happen in a chain. So this is this is where sequential models come into play. And so we'll talk about this in a few weeks' time, this particular model. Hidden Markov models. You may have also heard of conditional random fields, which are a very closely related model to the hidden Markov model. This is a kind of structured model that is based around a similar way of framing the features for making these predictions, for modeling what the next tag is going to be. But the idea is that we have algorithms to try and work out an entire sequence of tags for an entire sentence in one go. We don't have to have this error propagation property. We're not saying predict word 1, fix it, predict word 2, fix it, predict word 3. Instead, we can say over the set of possible tags, which as the sequence gets long, gets to be a very large set, but of those set of possible tags, which one is most likely? Which sequence of tags is most likely? There are a few differences in how we formulate these things in terms of independence assumptions. I won't go into this now, but we'll come back to it when we talk about hidden Markov models. But the cool thing is that there are dynamic programming algorithms for reasoning over these search spaces. Now, there's a model known as conditional random fields, which are another variant of these, and these are the state of the art, I think, by and large at the moment for these kind of tasks. And we'll talk about them when, well, actually I won't talk about them in detail, but I think I might mention them at the end of the hidden Markov model section. All of the algorithms for them are almost identical to the hidden Markov models, so they're very closely related. Okay, so one thing I wanted to touch on before we finish is how we deal with unknown words. So if we're tagging a language that has very rich word forms, so things like Turkish, where we have very, very long words that have a lot of morphological structure, then how do we tag these things, right? It's going to be complicated. If we just had features like what I described before, they're not going to be that useful. We're going to be ignoring the word form because we've never seen it before a lot of the time, right? If we haven't seen it in training, we're not going to have an idea on what to do in test time. So there are various ways that we can deal with this. We can try and use things that we've seen once to try and guess what the tag set might be for other rare things. And by and large, that's going to be saying a lot of them are nouns or verbs. And by and large, a lot of the taggers, when they have no idea, they say it's a noun. That's a pretty good way of backing off. Another technique is to use subword representations. So if you look at the suffix of the word or the prefix of the word or various other character-based information when we look inside of the word, then we can use that to make the prediction. And this works fairly well. So if you see something ends with an ed, perhaps it's a verb in past tense. If it ends in ing, that'll give you a clue as well. Okay, and a lot of the best methods are using these sort of subword level of information, even for English, which is a fairly impoverished language in terms of morphology. Okay, so let me summarize. Part of speech, it's the intersection between linguistics and text analysis. It's a very basic first step task that's used in lots of other NLP applications. So most NLP applications are going to have some processing that is involved, that is using part of speech, and that can then allow you to focus on certain aspects of the input. And there's I've talked about a whole range of different methods for doing it. Now, if you look in the notebook, we have a few different methods. They're very simplistic methods, but it gives you an idea on how we can frame the problem. I've shown you the reading here. 8.5.1 goes through some of the methods. The earlier bit, 8.1 to 8.3, goes through the actual formulation of what is part of speech. I don't expect you to know the methods in too much detail, but it's there for completeness. Okay, thank you. Hey there.